Okay, we're continuing the notes for 2A, excuse me, 2D. These are notes for 2D on Math 4, and we're picking up with example 7. And here's where we kind of review things that you learned in Math 3, or at least supposed to learn in Math 3, about the parent function of y equals 1 over x, which, as a rough sketch, it's going to look something like this. And it's going to come through here. And usually the parent function will hit one diagonal box away from the middle. Now here the x and the y axis are behaving as asymptotes. It will never touch either one of those axes. Now, so if I lose that, and let's start picking apart this. This is, I'm going to rewrite this. So that it's not slanted like that. All right, from all of this, we're going to pick apart that means that we are going to flip on the x-axis. Only when it's caught up in a parenthesis with the x does the negative cause you to flip across the y-axis, but this is flipping up and down. Now, that means that we are going left 2. That means that we are going down 3. Now, remember how the x and the y-axis met at the center and they were behaving like asymptotes? Well, we're going to take that center and we're going to go left 2 and we're going to go down 3. And he is going to be located there. And so we have a new set of asymptotes. One is looking there and the other one is coming down this way. Now, remember how I said that, oh yeah, it's going to flip, which means it's no longer going to be first quadrant and third. Now it's going to be second quadrant and fourth. And I think I mentioned that the parent function usually comes diagonally across one box and just kind of does that and starts hugging the asymptote, on the way out in either direction. All right, so that should be a good rough sketch of this guy. As we flip the axis, we went left 2 down 3, and that's where our meeting of asymptotes, that center, is going to be. Now I will say this, as far as stretching or flattening, that's going to show up on top of the fraction. Instead of a 1, it'll be a 2 or a 3 or a 0.5 on top, something like that. And all it really, there is a sense of stretching or flattening, but it's hard to see it as such when they look like this. When the number goes above 1, and this dot that is usually one diagonal box away from the middle, the bigger the number, the more this dot drifts away from the center. So these two blue curves will actually be moving away from each other as the number becomes 2 and 3 and 4. But as it gets smaller, 0.5, 0.2, 0.1, the blue curves will actually be merging toward each other, toward the middle. Of course, they will never quite reach the middle. It depends on how small their decimal is on top. Anyway, let's see another example of this. All right, we are going to go stretch by 2, and we're going right 3, and we're going up 1. Now, the right 3 and up 1, right 3 and up 1, that is our center, which means that our asymptote is going to do that and going to do that. Now, the question becomes, how do we stretch it to? And, my best way of thinking about this is to just kind of do a plug-in chart. Over on this side, we would normally think about it, the dot starting right there, which is where x is 1, 2, 3, 4. What happens when x is 4? We'll now plug it into this guy. Well, if I stick a 4 in there, underneath 4 minus 3 is 1, and 2 over 1 is 2. 2 plus 1 is 3. Well, 4, 1, 2, 3. All right, let's see what happens when we stretch out 5. When I stick a 5 under there, 5 minus 3 is 2. 2 over that 2 is 1, and 1 plus this 1 is 2. So we go 5, 2. And this kind of gives you a sense that this curve is going this way. Now we can play the same game over here. This is where x is 2, where x is 1. Where x is 2, when I stick a 2 under there, 2 minus 3 is negative 1 on the bottom. 2 over negative 1 becomes negative 2, and negative 2 plus that 1 gives me negative 1. Well, that's 2, negative 1. He goes there. You almost could look at this and begin to guess that the other guy is going to go there. If x were 1, 1 minus 3 is negative 2. 2 over that negative 2 is negative 1. Negative 1 plus 1 is 0. So yeah, we would be right. And so it goes that way. So that's, what if you wind up with a stretch or a shrink or something like that, I would suggest figuring out where the center is and doing the first couple of numbers on either side of that asymptote, and see if you get any points that help you get a sense of how this curve is behaving. All right, now on to a couple of piecewise problems. So we have a parking garage. It charges $6 for the first 4 hours. That would be a flat 6 for when x is, well, technically we need to say x is between 0 and 4. It could be 4 hours. It could be 0 hours. And then we'll go to the other side. And it is an additional 3 hours. That's like $3 an hour. But that's over and above 4. So we're doing this actually. So $6 for the first 4 hours, and then $3 an hour for everything beyond 4. Well, that's actually 6 plus 3x minus 12. Plus 6 minus 12 is a 3x plus 6. No, minus 6. Okay, and that is for everything above 4. So we're going to start with the red one first. If x is 0, then y is 6, which is up here. I guess it would be possible to walk in, pull the ticket out of the machine, and then change your mind. But at this point, they're still going to charge you $6 for pulling the ticket out of the machine. And you'll go for the first 4 hours, and we'll do this in terms of hours. And this is dollars. All right, so the first 1, 2, 3, 4 hours. It's going to look like that. And then in this case, if I plug in a 4 there, 3 times 4 is 12. 12 minus 6 is 6. So it is going to be an open circle here. But at this point, I'm going up 3 and over 1, which means I'm going up in that direction. And so that is roughly what my graph should look like. I got 1, 2, 3, 4 hours. I got 1, 2, 3, 4 5, $6. And so we can't really tell a whole lot about the rest of the graph other than we have an idea what the slope ought to be. Okay. Now the last one says we're renting it for a flat $45, and there are 2 levels to this. It's going to be a flat 45 anyway. Question is, if I keep it for 3 days or less, it is $7 a day. And if I keep it for more than 3 days, it is $5 a day. Now, you know something? I've done this already in some of my classes, but I just suddenly realized something, that this graph is going to look differently. And of course, it's not going to be easy to show it here. I think I'm just going to do it the way that I did it in class and leave it as it is. One of the things that we had trouble with is that we were talking about how many days. 1, 2, 3, 4, 5, 6. But we were also talking about the cost that it was going to be, and I was thinking maybe $50 per line. Something like that. All right, so when we graph the red, if we, like I said, we pulled the ticket out of the machine and decided not to park there, they're still going to charge us $45, which looks like it ought to be right about there. Now, at the end of 3 days, 3 days would be 3 times 7 is 21, plus 45 is 66. So at the end of 3 days, we should be at about there. Still not a very wide scale, so it's kind of hard to tell. But once we start doing here, we would say 3 times 5 is 15, plus 45 is 60. That's actually less than the 66 that was right here. And by the time we get to 7 days, 7 days is $80, which means something like about there. So $5 a day is a little bit flatter slope than $7 a day was. $7 a day, that should be a sharper rise. The blue should be a not quite so sharp rise. So that is what that graph should look like. Now, I'm going to toss something out here just to let it nag at you. If let's say that I kept it for 3.5 days, would they charge me half of the $5 for the half day? No, probably not. The way we really ought to be graphing this is what they call a step function, where you really should be doing like this, and each day goes up another step, because you really don't have fractions in between. I'm not going to redo this, but just understand that is an issue. That even the red part should be steps of day 1, day 2, day 3, and then day 4, day 5, day 6. They all should be steps like that. And we'll probably get more of a practice with that in future examples. I think that is it for 2D. So we'll call it a day there.